So in section 3.3, we are going to take a little stroll down memory lane back to long division. So think back to elementary school, probably 3rd or 4th grade, when you were learning how to do some long division. And we're going to review a little bit of that. And I promise I'll connect it to actual algebra and polynomials here in a little bit. And we're even going to connect it to graphing polynomial functions by the end of the section. But humor me for just a minute and let's look at long division as if we were back in 3rd grade, okay? All right, so this right here is saying 743 divided by 12. Okay, now one thing that we have to make sure we're aware of is which number goes in the division house, okay? And if you've ever heard, maybe the cowboy and the horse, I've heard elementary teachers say it that way. The cowboy leads the horse, so the cowboy would come first, the 743 would come before the 12. And the other part of that cowboy and horse story is that the cowboy can go inside the house, but the horse has to stay outside. So the 743 is the one that goes in the division house, and the 12 is the one that stays out. Okay. Now the official mathematical terms for these, the 743, the number that came first, is what we call the dividend. The dividend is the one that goes in the house. Excuse me, that got typed on the wrong side there. You divide by the divisor, so the number that comes second, in this case the 12, is what we call the divisor, and the divisor is what is outside the house. And then the answer you get to a division problem is called the quotient. And once you have your quotient, sometimes you have something left over called the remainder, and we'll talk about that in just a second. But just so you kind of know, the dividend comes first. It's what goes in the house. The divisor is what you're dividing by. The divisor divides the dividend. So it would be right there. Okay, so we're going to do this long division here. We're going to ask ourselves, how many times will 12 go into 7? Notice I'm looking only at the first place value there. 12 will not go into 7. Okay, a size 12 booty will not fit in a size 7 pants. So we go over one more space and we say, how many times will 12 go into 72? And it will go 6 times. 6 groups of 12 would be less than or equal to 74. Okay, now remember back in 3rd grade, after you put your number up here, you multiplied it back. So you say, okay, well, what's 6 times 12? 6 times 12 is 72. And then after you multiply, you always subtract. So I'm going to do 74 minus 72, which is 2. And then after you do the subtraction, you bring down the next number. So I bring down my 3. And then we start the process over. We ask ourselves, how many times will 12 go into 23? It'll only go once. Okay, notice how I'm lining up my place values up there. Then we multiply back. 1 times 12 is 12. After we multiply, we subtract. 23 minus 12 is 11. Okay, so our answer, the quotient, okay, the answer to the division problem is 61. And we had a remainder of 11. So back when you were in 3rd grade, at first when you did long division, if it didn't divide evenly, you put this R. So in this case, you put R11. And that was the way of saying, hey, there's a remainder of 11. There's an 11 left over. Okay. If you wanted to think about it as like 5 divided by 2, 2 will go into 5 twice. 2 times 2 is 4, and there's 1 left over. So at first you would just say, oh, there's 2 and then 1 left over. In other words, if there were 5 cookies and 2 people were sharing them, each person would get 2 cookies and there would be 1 left over. Eventually you learned, hey, that 1 that's left over, that 1 cookie that's left over, each of the 2 people can get part of that cookie. So 2 and 1/2. Each person would get 2 whole cookies and half of another one, okay? And then after you got really sophisticated and started learning about decimals, you learned that you could put a decimal and a 0, and you send the the decimal up and the 0 down, and you say, oh, 2 goes into 10 5 times 2.5. So the 2 and 1/2 or 2.5 is eventually how you learn to do the long division. But for right now, we're just going to say that this leftover number, in this case it was an 11, we're just going to put R11. Say that was our remainder. Okay? All right. So notice 743 equals 12 times 61. Okay? 12 times 61 is 732. But we needed 743. That means we needed that 11 more, that 11 remainder, to get back to our original 743. So 743 is 12 times 61 plus that remainder of 11. Okay? So they're just saying, hey, if you want to check, multiply your divisor and your quotient and then you may have to add on any remainder to get back to your original amount. Okay? Now, thank you for that stroll down memory lane from elementary school. Who cares? Why are we doing that? Well, because the same thing can happen with polynomials. Okay, if you think back to earlier in the course, we took polynomials like x plus 3, and we would add them to x squared plus 4x minus 7. Or we would subtract them, or we would multiply them using FOIL. But we never did division, and we intentionally skipped that so that we could talk about it now. Okay? All right, so what we will discover is, let's say we had some polynomial f of x. Okay, what we can do is divide it by some divisor, and we will get our quotient. That's why they're calling it q of x, q for quotient, plus whatever the remainder is divided by whatever that divisor was. So notice here when I did my 5 divided by 2, my fraction that I had for my remainder was my remainder divided by whatever my divisor was. Okay? All right. So let's try with some polynomials. Let's say we wanted to take this polynomial right here and divide by this one. Okay? We're going to use long division. Okay, so this is my dividend. It's going to be the one that goes in the division house. We are going to divide it by the divisor 2x minus 5. Okay? All right, so I'm going to ask myself, how many times will 2x minus 5 go into this thing? And in order to answer that question, to do that in my head, I'm going to ignore the 5 for just a second. I'm going to ask myself, how many times will 2x go into 2x to the third? Or better yet, what could I write up here so that when I multiply back by 2x, I get 2x to the third? And the answer to that is x squared. X squared times 2x will get me back to 2x to the third. Now, where should I write that x squared? I'm going to put it above my other x squared. I'm going to line up the like terms. Okay? All right, so now I'm pretty sure that x squared is the quotient that I need to write up here. So now I'm going to multiply back. X squared times 2x is 2x to the third. It's very good that they match. If these did not match, then I did something wrong. X squared would not have been the correct thing to put up here. Now, I multiplied x squared times 2x, but I also need to multiply it by the minus 5. So x squared times negative 5 is negative 5x squared. So I have multiplied it back. Now, up here, after we multiplied, we subtracted, yeah? So I need to subtract. Now, in order to subtract these, I have to subtract both parts. I have to subtract the 2x to the third, but I also have to subtract the negative 5x squared. Now, when I subtract a negative 5x squared minus a negative, that's going to become a plus. So what some people do is they just say, hey, change the signs of this stuff. They multiply it, and then they change the signs. But when you change those signs, what you're really modeling is subtraction. Okay? So I've changed the signs to indicate that I'm subtracting. 2x cubed and negative 2x cubed cancels out and makes 0. If this does not cancel out to make 0, then we've done something wrong. That should always happen. Okay, negative 11x squared and 5x squared is going to combine to be negative 6x squared. All right, after we subtracted, we brought down the next piece. That's what we did when it was plain numbers. So that's what we're going to do here. We're going to bring down the next piece. We're going to bring down the plus 13x. And now we start the process over. We ask ourselves, how many times will 2x go into negative 6x squared? Again, I'm ignoring the minus 5 and the 13x. How many times will 2x go into negative 6x squared? Or what can I write up at the top so that when it multiplies by 2x, I get back to negative 6x squared? Well, 2 times negative 3 will make negative 6, and x times x would make x squared. So I bet it's negative 3x. Here's another clue. The next place over in my place value was plain x's. So I needed some number and then an x because I'm in the plain x position for place value. Okay, now we multiply back. Negative 3x times 2x is negative 6x squared. It's a good thing that those match. Negative 3x times negative 5 is positive 15x. I've multiplied. Now it's time to subtract. When I subtract, these signs will change. I'm subtracting negative 6x squared. That will make it a positive. I'm subtracting a 15x. I'm going to mark that out and make it a negative. Combine like terms. Negative 6x squared and positive 6x squared is 0. 13x and negative 15x is negative 2x. Bring down our next piece. Bring down our next term. And now we ask ourselves, self, how many times will 2x go into negative 2x? Now look at your place value and let that help you. I'm in my constant position. Positive 15 is just a constant. So this is just going to be a constant, a whole number. So what number can I put up here that when I multiply by 2x, I get negative 2x? That's going to be a negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 5 is positive 5. I've multiplied. Now I need to subtract. Subtracting will change their signs. That one's a positive now, and that one's a negative. Negative 2x and positive 2x cancels. They should always cancel these first terms. If they don't, then we did something wrong. 15 and negative 5 is positive 10. That positive 10 is our remainder. So back in 3rd grade, you would have put R10. Okay? We are a little more sophisticated than that. Since this is a positive 10, we're going to put plus 10 over whatever we divided by. And we divided by 2x minus 5. So the answer to our division problem, the quotient, will be x squared minus 3x minus 1 plus the remainder of 10 divided by whatever we started with, which is exactly what we do when we had plain numbers. 5 divided by 2 was 2, the remainder of 1, so there was 1 out of 2 left over. Okay? And that's exactly what happens here. Let's try another one. This polynomial divided by x minus 3. Okay, now notice one interesting thing here. This first part is my dividend. It's going to go in the division house. X to the 5th minus 3x to the 4th. Now notice one thing here. We are missing some pieces. They've got an x to the 5th, an x to the 4th. They skipped over x to the 3rd and x squared, and then there's the 12x and then the constant. So if anything is missing, if they skip over any pieces, we are going to put zeros in for that. So we're going to put in a 0x to the 3rd. We're going to put in a 0x squared. And then we resume with our plus 12x and our minus 33. Put zeros for any parts that was missing. Divided by our divisor, and our divisor is x minus 3. Notice our divisor wasn't missing anything. It started with a plain x, and then it had just a constant, and that's fine. Let's say it had started with like an x squared and minus 3 and was missing the plain x, then we would put in the plain x of 0 here. Okay, so if anything that's missing, whether it's in the dividend or the divisor, you have to put a 0 for anything that's missing. Okay, so we ask ourselves, how many times will x go into x to the 5th? And the answer to that is x to the 4th. It ought to be one place over. X to the 4th times x will get us back to x to the 5th. X to the 4th times negative 3 is negative 3x to the 4th. We subtract, which will change the signs of those pieces. X to the 5th cancel. Negative 3x to the 4th plus 3x to the 4th is 0. Okay, now that's interesting. So I've got 0. Well, then I can bring down this part, but x will go into 0x 0 times. It will go into the next part 0 times. Finally, I have to go all the way down to 12x before x will ever go into my new piece here. Okay? So, how many times will x go into 12x? And it will be 12 times. So notice, I actually get to skip down to my constant here of 12, and that's a positive 12. 12 times x is 12x. And 12 times negative 3 is negative 36. In fact, I might as well go ahead and bring down that minus 33 as well. Okay? When I subtract, these signs change. 12x and negative 12x cancel. Negative 33 plus 36 is positive 3. 3 is our remainder. So the quotient, the answer to this division problem, is x to the 4th plus 12 plus this remainder of 3 divided by x minus 3. Now, I'm going to let you know a little secret. This one was kind of messy and challenging. I'm actually going to show you a shortcut on the next page for what to do when you're dividing by just x plus a number or x minus a number. So don't stress too much if the zeros were confusing for you. I'll show you a little shortcut on the next video there that will help us. Okay?